Hello friends, in this video we are going to see dimensionless number. Let's start. So there are 5 dimensionless number: Reynolds number, Froude number, Euler's number, Weber number and Mach number. Correct. So we are going to see one by one all these 5 dimensionless number. Let's start with the Reynolds number, the first one. Reynolds number. So what is the basic definition of Reynolds number? It is defined as the ratio of inertia force to viscous force. It is defined as the ratio of inertia force to viscous force. So Ra is the symbol we are using for the Reynolds number, and inertia force to viscous force, this is the formula. So we are writing Fi in the suffix, and Fv is for viscous force, inertia force to viscous force. Inertia force is rho Av square, and your viscous force is shear stress into area, tau into A. This formula already we have seen in the last slide. That is viscous force equal to rho Av square, that is mass into acceleration, right? What is mass? Mass into, what is your force is nothing but mass into acceleration, correct? Acceleration. And what is mass? Mass equal to density into volume, correct? Volume into acceleration. Acceleration is your V by T, correct? So volume can be again written as area into length, and T I will write here, and V is already there, correct? So I can write rho A, L by T is your V, and this V is square, so rho Av square. So inertia force. And viscous force, that is shear stress into area, tau into A. So what is the unit of tau? Newton per meter square into meter square. So this gets cancelled. So you are getting the Newton. That is the unit of force, viscous force. Shear stress into area. So when you multiply the shear stress into area, that is called as viscous force. So rho Av square, and you know the formula of tau, mu into du by dy from the first chapter, Newton's law of viscosity. Mu into du by dy for the Newtonian fluid into A, area, correct? Now rho V square we have written on the numerator. Why? Because this A gets cancelled here. A gets cancelled here. Rho V square. So mu is here. Now du. Du can be written as V, and dy is your length. Correct? V by. So for the property. So what we can write now finally? Ra equal to. So one V will be cancelled, right? One V is cancelled. So V square and V is cancelled. So in the numerator we are having rho V L by mu. That is the formula of Reynolds number. What is L? L is any linear dimension. When you are using for pipe, it can be D. L is replaced by D diameter. When you are using the flat plate, that time it will be rho U infinity X. It will be the distance from the leading edge of the flat plate, U infinity X. Or in case of open channel flow, L can be replaced by the D, depth of flow. Okay, so this is the formula for Reynolds number. In case of pipe, yeah, that's what it is written. In case of pipe, R equal to rho V D by mu. Very important. So in this chapter, in mechanical and civil, we are going to see pipe as well as open channel for civil only. So rho V D by mu and V D by nu. Nu is your kinematic viscosity. What is nu? Nu is your kinematic viscosity. And I hope you remember the unit of kinematic viscosity, meter square per second. Correct? Meter square per second. Okay. We'll go to the next dimensionless number. Froude's number. It is defined as a square root of. So this is a new word actually. Square root was not there in the last dimensionless number, Reynolds number, but here it is there. It is defined as the square root of ratio of inertia force to gravity force. That means how we'll write? It is defined as a square root of, you take the square root first, ratio of inertia force to gravity force. So Fi by Fg. Inertia force to gravity force. That is what it is written as Froude number. Fr equal to inertia force to gravity force. So root under of Fi by Fg. Fi is always rho Av square, you know that. And what is Fg? Gravitational force, mass into acceleration due to gravity, mg. So rho Av square. Again, mass is written as density, and V is your volume. 1 second. Yeah. Into acceleration due to gravity. So mass is written as density into volume. into G. So this volume can be written as area into length, correct? This volume can be written as area into length into G. So you can cancel rho and area can be cancelled here, right? So what we are getting finally, root under of V square is V by root under of Lg. That is what it is written as, root under of V square by Lg. So you can take V out. That is what I have written here. Correct? I have written here V by root under of Lg. This is also a formula for Rod number. In case of pipe, L is replaced by D, linear dimension. Root under V square by GD is nothing but V by root under of GD. Okay, in case of pipe, you can write V by root under of GD. In case of open channel flow, you can replace D by depth of flow. Okay, that we are going to see in that particular topic. Next, dimensionless number is Euler's number. What is the definition? It is defined as the square root. Again, the square root is important here. The square root of ratio of inertia force to pressure force. So inertia force is there in all the dimensionless number. Only denominator is changing. Inertia force to pressure force, Fi by Fp, rho a V square. Pressure force is pressure into area, right? What is force? Force equal to pressure into area. So because we are taking pressure, this is also known as pressure force, P into A. So A gets cancelled. So you are remaining with the rho V square by P. So what is Euler's number final formula? V by root under of P by rho. Okay, what is the unit of Euler's number? No unit, because they all are dimensionless number. Next is the Weber's number. It is defined as the square root of ratio of inertia force to surface tension force. Weber number is your surface tension force. What is Weber number? Inertia force to root under. Root under is very important. It is mentioned here. You can see. Except Reynolds number, everywhere you will find the square root. Inertia force to surface tension force, Fi by Fs, rho a V square by sigma into L. Correct? You know that whenever you are writing the surface tension force Fs, suppose, then you have to write sigma into L. Sigma is the surface tension, and if you multiply with the L, then only you will get the force. Sigma into L. So rho area is your L into L, L square into V square, sigma into L. So one L gets cancelled. Correct? So you can write definitely Weber number equal to root under of V square by sigma by rho L. V square or V by root under of sigma by rho L. This is the formula for Weber's number. Let's go and see the next slide for the last dimensionless number, that is Mach number. It is defined as the square root of, here also you can see square root of ratio of inertia force to elastic force. So what is elastic force? Elastic force is elastic stress into area. You can see here. Elastic stress into area. So Mach number is inertia force to elastic force. Fi by Fe we are writing. Fi inertia force is always rho ev square. For this Fe we are writing elastic stress into area. Elastic stress into area. So in this case, Mach number is rho ev square. What is elastic stress? Elastic stress is K here and area is A. So A gets cancelled here. So rho, okay, after writing L it is cancelled here, no problem. You can continue to write or you can cancel here itself. So rho area is your L square and then V square. K is as it is. Area is again written as your L square, right? L square. So A is again written as your L square. So this L square cancel. So M is equal to V by root under of K by rho. Correct? So V is the velocity of the object and K by rho is also written as C. C is the velocity of the sound. Correct? C is the velocity of the sound, or in some book it is also written as A, which is equal to root under of gamma RT. That is from the derivation for the compressible flow, gamma RT. And what is gamma? Gamma is your Cp by Cv, whose value is 1.4 for air. And R is your gas constant, characteristic gas constant. And T is your temperature in Kelvin. Okay, so we have to use only this formula, M equal to V by A. And what is the unit of Mach number? No unit, dimensionless number. So velocity of the object, and whenever you are calculating the Mach number, you have to write the velocity in terms of meter per second. Don't write kilometer per hour, okay? Meter per second always. So this is all about your dimensionless numbers. Thank you.